Hi Physics fam, we are going to do a forces problem that involves a little bit of kinematics. So we have a golf ball that's hit by a driver and it accelerates from rest to 67 meters per second in 1 millisecond. And we're trying to figure out the average force that the golf ball experiences. So our force equation is going to be Newton's second law, F equals ma, and we are solving for force in this situation. We are given the mass here as 0.046 kilograms, and then we don't actually have acceleration. It says that it can accelerate from rest to 67 meters per second in 1 millisecond. So we have information about the acceleration. So let's list those things out. We know that we're starting at rest. So we have an initial velocity of 0 meters per second. We have a final velocity of 67 meters per second. And we know that this occurs over a time period of 1 millisecond, or 0.001 seconds. And we do want to make sure that we are using the correct units here. So all of these three things can relate to acceleration using one of our kinematic equations. We know that our final velocity is equal to our initial velocity plus acceleration times time. So our initial velocity we identified as 0, and we can plug in the remaining information. We have 67 meters per second equals acceleration times 0.001 seconds. So when we solve for our acceleration, we end up with 67,000 meters per second squared for our acceleration. Now it doesn't want our acceleration, it wants our net force, or average force, that the golf ball is experiencing. So we can use this value and plug it in to Newton's second law. So we have F equals the 0.046 kilograms we have from the problem, multiplied by the 67,000 meters per second squared that we just solved for our acceleration. So when we multiply those two together, we end up with a force of 3,082 newtons. And that is the average force that the golf ball experiences.